Hello friends, welcome back to the today's video of StarPro for Fresh Civil Engineers. In the last video we discussed about the analysis of single span beam, in which we have analyzed three different type of beams, that is first simply supported beam subjected to UDL, then second simply supported beam subjected to point load, third simply supported beam subjected to point load and UDL. Now in the today's video we are going to discuss the analysis of continuous beam subjected to different type of loading condition. So here we are considering a continuous beam A, B, C, D, E, in which subjected to different type of loading conditions, that is nothing but here the point load, UDL, then again a triangular load, then the movement, and we are going to analyze this beam using the StarPro. So let's start with that. Start with the new, select here plane, next beam 4, next finished. Okay, now selecting the front view. Now here the beam, the span, total span of the beam is, first AB span is 4 meter, then again BC 4 meter, then next 5 meter, and the next at 2 meter movement is there. So here we have to add one node, again we have to consider over here at 1 meter, and then here 2 meter and 1 meter, right? So in this way we have to add the nodal points, considering here total span is 4 plus 4 8 plus 5 13 plus 4, that is nothing but the 17 meter. So considering this, increasing the grid size here, edit, in X direction I increase the size of the grid up to 17 meter. Okay, now whatever this node, selecting this node cursor, just deleting this node. Okay, now add the first span of 1 meter, then next span of 2 meter, then again for 1 meter, then next for 1 2 3 4 meter, next span of 5 meter, then next of 2 meter, and again lastly 2 meter. Okay, so in this way we have added all the node points as per the beam, right? Now let's start with the general conditions, that is nothing but the supports. So create the supports, so create the pin support over here, add. Now here at A there is a fixed support, then at B, C, D and E there is a pin support. So considering that, we have to create the fixed support also, so adding the fixed support here. Okay, now support 3 is, selecting the node cursor, support 3 assign to the selected node, assign, yes. Then let's get displayed the node points, shift plus N, so all the nodes were appeared over here. Then support 2, select the node cursors that will be provided at support node number 4, then node number 5, then next at node number 6 and node number 8. At these 4 nodes support 2 is there, so assigning this, assign, right? Now supports are get assigned. Let's go for the load and definition. So load case details, add here load case 1, add, close. So in load case 1, first of all, the first there is a point load of 25 kilonewton applied, so we are adding the nodal load of 25 kilonewton. Then two uniformly distributed loads are there, 10 kilonewton per meter and 25 kilonewton per meter. Let's go with that. So first go for nodal load of minus 25 kilonewton, add. Then next there is a uniform force. Now uniform force, this will be applied. The first will be of minus 10 kilonewton per meter. Then add this one, and the another is minus 25 kilonewton per meter. Add that one. Now the next load is this triangular load of 35 kilonewton per meter and the moment of 50 kilonewton per meter. So here going for this linearly varying load. So this is the varying load, that is nothing but the triangular load. The value of triangular load is minus 35 kilonewton per meter. Adding this load, and lastly the uniform movement. So here we have to apply that concentrated movement. Okay, and the value of the movement is given 50 kilonewton per meter. So that movement we are adding over here. It is nothing but the, now the nature of the movement is clockwise, so 50 kilonewton meter is the movement. Add over here, close. Right, now assigning the loads. So first assigning 25 kilonewton load. So select the node cursor at point 2, 3, and then here at this support. So assign to the selected nodes, assign. Okay, then next uniformly distributed load of minus 10 kilonewton per meter. So considering the beam cursor, assign to the selected beam, yes. Next load, uniformly distributed load of minus 25 kilonewton per meter. Selecting the beam, assign, yes. Now next is a triangular load. Select the beam, assign, yes. Then a concentrated bending moment. Select the node cursor, okay. Right. Now here we have to add the load case 1, add over here a concentrated bending moment value, displacement, then member load, hydrostatic, concentrated force, concentrated moment, uniform moment. Taylor time is response, repeat frequency. So here we have to assign that concentrated moment. So moment value is minus 50 kilonewton meter and which is acting at a distance of 2 meter, and the moment is acting in a global z direction. So here add that moment, close. Now this z moment assign. So here this is a moment. Now to decrease the arrow size, you can go here in a labels, here you can go in a scales, and in that one you can increase the size of this as let's say 45, apply. So this the arrow sizes get reduced. Again if you further increased, then again the arrow sizes get reduced in. Okay, so this is a bending moment applied over here, and this bending moment is applied at a distance of 2 meter. So here close. Now in this way all the values of loads are get assigned over here. You can check the values by putting this load values over here. Okay, so now this is a continuous beam. Now we have to go in the property, define the cross section size, let's say rectangle size, then 0.3 section I'm selecting over here, then add that section size, close. I'm selecting the whole beam, assign, yes. Okay, now go in the analysis and print, select all, add over here, close. So perform analysis, assign, then go in the analyze, run analysis, save. Okay, so 0 errors, 0 warnings, done. Now you can check over here, you can press the scroll but control and scroll up and down to check the value of shear force. So here you can see the triangular load is there, so the shape of the shear force diagram is second degree curve, then here it is constant as there is no any force. Similarly over here a constant, then UDL, then here again UDL. So in this way you can plot the shear force diagram for the continuous beam also. Now you can check the bending moment diagram also in the z direction. Okay, over here, so this is the bending moment diagram for the section. Then similarly you can check over here the deflection curve also. Press the control and scroll down the bar, you will get this deflection curve at different location points. Similarly over here you can go in the post processing mode, apply, okay. You will get here the values of all the relative displacement and all at different locations, then the reactions at different supports, similarly the values of bending moment also. Even you can plot the report also for this output result, that is nothing but the beam end forces. Then you can go in the maximum bending moment, maximum shear force, maximum axial force. Just you have to take all these values and transfer it over the right side window. Okay, so you will get the result, maximum axial forces, right. Then similarly the next maximum bending moment, then beam end forces, all the values of the selected parameters that can be appeared over here. Now up till now we have see the different type of beams. Again we have seen the analysis also. There is one more point in the stat flow, that is nothing but here the stat editor. Whatever the input we are giving to this stat flow, that all input is typed in the form of a program which is gets stored in this stat editor. Okay, so here you can see that joint coordinate, then member incidents, material properties, then similarly the support conditions, pin support, then one is for fixed support, different type of load cases, all the input value that will be get stored in the form of this program that is called as an STAD editor, right? And sometimes if you want to make some changes over here in the main modeling, those changes you can make through this STAD editor also. Similarly over here nearer to that there is a option of STAD output. Selecting this STAD output, here you will get the total output result, that is nothing but the initially this will be the STAD editor input program, and then in this output whatever the analysis performed, different load conditions, then forces, then the moment, all those results that you will get in the form of this output result. You can select here the applied load and the reaction load likewise over here. So these are the two things where you can directly get the input and output result over here, right? So you do the practice of solving many number of problems. If you have any problem or if you have any doubt, you can ask those doubt in the comment box. Okay, till that, thank you and all the best.